Summation notation. This is the Greek letter sigma. In mathematics, it means summation or sum of a function or discrete function, a of I. Down here below is we call this the index. So index we're using is I, and this is where it starts. And it's always going to be integer values. So I equals 1, and it's going to increase to the next integer and keep going. You keep plugging them into this function until you reach the upper limit in, and then you stop. And you take those individual values or numbers you are plugged into the function, and then you sum them together. Let's do an example. Suppose we want to take I equals 1 to say 5 of the function. We'll just say 2I plus 3. Okay. So what you're going to do is you're going to start with 1 and plug it into this function here. So let's write it below here for more room. So the first value will be 1. So we're going to plug in 1 for I. So we'll have 2 times 1 plus 3. So that's the I equals 1 term. Now we go to the next value up, which would be 2. So we plug in 2 for I, so it would be 2 times 2 plus 3. Now you have your I equals 2 term. Go to the next one, which will be 3. So replace I with 3. So it'll be 2 times 3 plus 3. There's your I equals 3 term. We're going to keep doing this until we reach 5. Next one will be 4. I equals 4 term. Now we reach the final one. We know it's the last one because up here it's the upper limit, 5. So that's the 5th term. So what we did was we generated terms from I equals 1 to 5 by plugging them into this function here. Now the sigma notation means what we're going to do is we're going to add them all together. So we're going to put plus signs between them. Now just compute. So this will be, the first one will be 2 times 1 plus 3 would be 5. 2 times 2 would be 4 plus 3 makes 7. 2 times 3 would be 6 plus 3 makes 9. 2 times 4 plus 3 makes 11. 2 times 5 plus 3 makes 13. Add them all up. 45.